we're going to talk about slope. If I put two ordered pairs down here and here, and then I connect those two with just kind of a little line segment, I can clearly see that that's not a straight up and down line. It has a curvature to it. Sometimes we talk about its angle, but when we talk about lines on a grid, we talk about slope. And slope has to do with how much up do I go and then how much over do I go. This is clearly an up 3 over 1. So we write slope as a ratio. What I kind of think about this is this vertical distance here is my change in y. And if I kind of use a delta to represent change, that's change in y. This little symbol, the triangle, means change in y, and I take that over a change in x, and x is the horizontal. We sometimes call that a rise over run. You might have heard that before. But right now I'm just thinking about this as to what that would be. Right here, my rise would be 3, and my run would be 1, so I'd get a positive 3. If I do a slope over here and take this, and then connect those, what I can see is that my change in y, this is actually a negative 5. I'm going down 5, and then I'm going right 1. So if I do my rise over run there, it'd be negative 5 over 1, or negative 5. That would be the slope of that. Now, I could actually take some points here and maybe do this to this right here, and that slope is going to go up 2 and then right 4. Now note that it doesn't matter if I do it that way or if I go right 4 and then up 2. It's still a slope of up 2 and over 4. My change in y is 2 and my change in x is 4, and this can simplify to 1/2. And if I think about that, if I go over 4 and up 2, that's the same as going over 2 and up 1, and that would actually create a smooth line there. I could do slope by picking these 2 points. Now those 2 points are going to have something the same. That's really an up 0 and over 3. So if I go up 0 but over 3, my up 0 over 3, that's just a slope of 0. Or I could put 2 points like this, and I would call that that'd be an up 2 but over 0, and I'm dividing by 0, so we call that undefined. And an undefined slope is of a vertical line. So formally, I want to think about slope is change in y over change in x. And we can calculate slope if I'm actually given the ordered pairs of 2 points. We can calculate slope if given 2 points. We'll call these points x sub 1, y sub 1, and x sub 2, y sub 2. Those just represent 2 different ordered pairs, 2 different xy's. So if I do a change in y over change in x, my change in y could just be a subtraction, y1 minus y2, and then I need to do the corresponding change in x, x1 minus x2. Now, I could take that and switch the order, y2 minus y1, but then I would have to switch the order of the x's because I want to subtract those in the same order. And this is just another way of saying change in y over change in x, or rise over run. They all mean the same thing. So sometimes I want to find the slope, not if I've given a graph, but maybe I want to find the slope of 2 ordered pairs. So if I want to find the slope of maybe the ordered pairs 3, 1 and negative 7, negative 5, what I want to do is just set this up as a subtraction. We use the lowercase m to mean slope, and I'm going to say that that's equal to y2 minus y1 over x2 minus x1. Now, it doesn't matter which of these points we call y1 and or x2 y2 or x1 y1. I just need to keep it consistent. So what I'm going to do is actually set this up where I'm just going to do something minus something over something minus something. That way I'm just filling things in and I'm not worrying about signs. I really want you guys to set this up for the first lesson, because then you're going to be less likely to mess signs up. Then I'm going to take maybe this point and stick it in right in there. 3, 1. Y goes on top. And I'm going to take this point and stick it in here. -7, -5. Again, y goes on top. Then I'm just going to simplify. This is actually 1 plus 5 over 3 plus 7, or 6 over 10, and that simplifies to 3 over 5. And that would be the slope of these 2 points. I could check that by graphing, and I'm going to do that one right here. I'm just going to graph these 2 points on a grid. So it's 3, 1 is right here, and -7, -5 would be right there. And if I connected those, this is saying my slope is 3/5, so I should be able to go up 3 over 5. Let's see, up 3 and over 5. But I'm not. Something's not right here. And I see it. I did not graph 3, 1 right. So erase that. 3, 1 is actually right there. Connect these, and now I can check this for, am I going up 3 over 5? Yep. There's an up 3 over 5, and there's an up 3 over 5. So slope is a very good way to check, did I graph the points right? Is the curvature of the line correct? This represents, again, this is up 3, right 5. So let's do some more points. Let's graph the point -3, 2, or not graph the point, but let's find the slope of -3, 2 and -7, -1. So same thing, I'm going to say slope is equal to, and I'm going to do something minus something over something minus something. And I'll take the first point and just stick it in as -3, 2, and the second point as -7, -1. Then I'm going to simplify this. 2 minus a -1 is the same as 2 plus 1, and -3 minus a -7 is the same as -3 plus 7, and I get 3 over 4. So if I have 3 over 4, let's check that by graphing and just kind of make sure that I've got this right. 3 over 4 would be -3, 2, -7, -1, and let's see, -3, 2, -7, -1, 1, 2, 3, 4, 5, 6, 7. Looks like I made the same mistake again. -3, 2 is actually right here, and now that up 3 over 4 matches. So once again, we're looking at where 2 ordered pairs need to follow the slope. If I did my calculations correctly, it should match. Now that slope means the entire line. It's not just that one piece. Everything in here has sort of an up 3 over 4 ratio to it. Let's try the slope of a couple more. Let's go -1/2, 2, and 4, -3. So I'm going to do the same thing. Slope is change in y over the change in x. And I'm going to plug in these points. This point's going to go here, -1/2 and 2. Remember, y is on top. And then 4 and -3. Let's do my addition. I've got 2 plus 3 over -1/2 minus 4. 2 plus 3 is 5, and -1/2 minus 4 is -1/2 minus 8 halves, or -9 halves. That's not a whole number ratio. I want to get that in a whole number ratio, so I'm going to multiply by a 2 over 2, and I get 10 over -9, which I can write as -10/9. That would be my slope. We can actually check this. So if I graph the points down, -1/2 positive 2 would be right here, and 4 -3 would be right there. Now, it doesn't look like I can very easily check that this is down 10, right 9, but this is actually 1, 2, 3, 4, 5. This is down 5 and right 4.5. It should make sense that if I go down 5 and then right 4.5, and this is down 5, that if I doubled that, I would get down 10 and right 9. And that's the same ratio as before. So I'm okay. That matches. Another problem type we can do is if I say, let's find the slope of 2, 5 and 2, negative 10. And if I calculate 2, 5, and 2, negative 10, my slope would be equal to change in y over change in x to 5 and 2, negative 10. And I get 15 over 0. Well, I'm dividing by 0, so that's undefined. And that's okay. I can just write undefined and move on. Negative 3, 2, and 1/2, 2. And if I say slope is the change in y over the change in x, get 2 minus 2 over negative 3 minus 1/2, and then I get 0 over something. I'm just going to put 0 over something because I don't even need to calculate that. That's just 0. So that's okay. Slope is 0 versus slope is undefined. Make sure you get these two straight because they're not the same thing. Lastly, we have a problem type where I could say I have an ordered pair 7, k and 1, negative 3, and I know that the slope is 1/2, and I want you to find k. Well, I'm going to just set up the same thing we did before. I'm going to go m is equal to the change in y's over the change in x's. If I plug in the first point, I get 7k, and the next point would be 1, negative 3. And then I'm going to simplify that. That's actually k plus 3 over 7 minus 1, and that's 6. So that's my slope. But it actually says 1/2 is my slope. So I'm going to plug this down here and make them equal to each other. This should be equal to 1/2. So now I have an equation. K plus 3 equals 1/2. Well, what k would make that true? In order for that to be true, I'd want to actually do a cross product. 2 times k plus 3 equals 6, or 2k plus 6 equals 6. Subtract 6 from both sides, and I get 2k equals 0, or k equals 0. So the k equals 0 would make that happen. Let's try one more of that. You might want to pause this and try this on your own and then come back. We're going to find r, so negative 1/4, 2, and 3k minus 1 has slope of 1/7. So I'm going to do the same thing. My slope is equal to change in y over the change in x. Plug in my first point, negative 1/4, 2. My second point is 3, and then k minus 1. And right now I'm just going to go ahead and put this equals 1/7 right here. It's kind of good to get that out of the way. I'm going to take the top and simplify that. 2 minus k, this negative would distribute and make that a plus 1 over negative 1/4 minus 3. And that's equal to 1/7. I'm going to keep simplifying. I've got 2 plus 1 is 3. 3 minus k over negative 1/4 minus 3. Well, 3 is really 12/4. So that's negative 13/4. That's equal to 1/7. I could cross multiply right now, and that would be okay. So let's just go ahead and do it. Negative 13/4 equals, and then 7 times 3 minus k. But I'm definitely going to want to multiply by an LCD of 4 here. And if I do that, then on the left side and the right side, multiply by 4, I get negative 13 equals 28 times the quantity 3 minus k. Or 28 times 3 is 84 minus 28k. Then I subtract 84, and I get negative 97 equals negative 28k. Divide by negative 28, and I get k would be equal to 97/28.